Let us begin with a new topic, that is performance tuning. Okay, so now tuning of the Golden Gate, it depends on the measurement. How Golden Gate is performing is is measured with the term lag. Okay, now let us understand what is the lag over here. What is the lag? What does the lag means? Okay, so now we have three major components in Golden Gate. One is extract, which is capturing the data from the database. Then it's a pump, which is reading from the trail file, sending to the target. The replicate, which is reading the target trail file and sending to the database, uh, committing on the database, I would say, doing the transaction in the database on the target side, right? So I'm sorry. So what would be the lag for the Golden Gate? So lag for the Golden Gate, if I talk about the total lag of the Golden Gate, is the elapsed time between the transaction that is committed on the source server and the transaction that is committed on the target server. So difference in the time would be the total lag. So total lag is the time difference, which is it is committed on the source system, and the time which is it is committed to the target. So if a transaction is committed at 10 o'clock in the source system, and the same transaction get committed in 10:10 in the target system, the lag would be 10 minutes for that particular transaction, or maybe overall for the Golden Gate. Okay, so that would be the lag time of the Golden Gate. Now each component, now let us understand each component its own lag time. Okay, so these lag times sum up the total lag time for Golden Gate, right? Okay, so now extract lag time would be the lag time which would be in between the lag time from the from when the transaction is committed in the source system and the transaction is being written to the trail file. So the difference in the time where the transaction is being written or being committed on the source system and the transaction being written on the trail file, the difference in the time would be the extract lag file. Similarly, for the pump, the lag is the additional lag. Okay, additional lag, that means is for the extract, if the lag is 5 minutes, so it starts from that time. So the transaction which is committed in the source system and the transaction which will be written in the target trail file, so that total would be the pump lag. Okay, and similarly, then the replicate side, the transaction committed on the target system and then the transaction which is committed in the source system, so that transaction, that lag is known as the replicate lag. So replicate lag is actually the total lag time for the Golden Gate. Okay, that is the difference in the transaction get committed in the source system and the transit system. So the replicate lag would be the sum of lag of the extract lag, pump lag, and its own lag internally. Okay, so difference in time, it is reading the time it is taking from reading to tail file to the replicate. So replicate lag would always be the highest. So where the lag is being shown, so we have different ways to show the lag. Even info all command also shows the lag, right? You might have seen it if you're working for, now you have worked on Golden Gate, you have installed configured Golden Gate, so the info all you would be seeing the lag time. So replicate lag time would always be highest because it is the sum of the lag of all the two processes, all the three processes, and that is equivalent to your total lag time actually. So how you can troubleshoot? When we are troubleshooting, we have to troubleshoot from the target end. Okay, we have to troubleshoot from the target end, monitor the lag at the target end. So assume the target end is showing a lag of 1 hour. Okay, it is showing a lag of 1 hour, and when then what we should do, we should go at the pump side first of all. Okay, assume now pump is also showing a lag of 1 hour. Okay, now pump is also showing a lag of 1 hour. Then what we should do? Okay, so if pump is showing a lag of 1 hour, then definitely there is no problem with the replicate side, right? Because the replicate lag would be 0 because it is getting a transaction which is already 1 hour delay from the pump. And if the pump lag is 30 minutes, then it means is the lag on the replicate is 30 minutes. 1 hour minus 30 minutes, 30 minutes. So I need to start working on the replicate side. Okay. Okay. So assume we are first assuming the replicate uh, lag is 1 hour, pump lag is 1 hour. I went to extract lag is 0. So then where the problem is? The problem is only with the pump. Okay, pump lag is the sum of lag of extract and pump. Replicate is the sum of lag between extract, pump and replicate itself. Then if pump lag is 1 hour, then means there is no problem in the extract. Extract is capturing the data as soon as it is committed on the source. That is lag is 0. It is lag, pump has a lag of 1 hour. So the problem lies with the pump. Pump is delaying the data writing to the target trail file. So 1 hour is the gap data read from the uh, 1 hour is the gap, it is reading from the trail file writing to the target trail file. So pump has a problem, so you have to start troubleshooting on the pump side, or assume if the extract lag is 0, pump lag is 0, replicate lag is 1 hour, then only the problem with the replicate. Okay, so it is taking time of reading the data from the target trail files and writing to the target database. Might be a database, might be the target database is slow, the replicate itself is slow doing all of this task. Okay, so we have to monitor the lag by working from the target to the source side. So that is the thumb rule for troubleshooting. So assume the extract lag is 1 hour, pump lag is 1 hour, and replicate lag is 1 hour. It is showing like this. So where's the problem? Then in that case problem lies with the capture process, right? The extract process. Okay, because pump and replicate are just anyways getting the lag from the capture. So if pump is extract is processing slow, it getting the data 1 hour delay. The pump and replicate also get the data in 1 hour delay, right, from the source system. So capture which has the problem, it is has the problem of lag of 1 hour. So we have to start tuning the capture process. Okay, so now so for now what we have learned, the same summarization in the slide is total lag is the lag time between the transaction committed in the source system and the transaction committed in the target system, and that is the lag of the replicate as well. Okay, so the capture is the lag, the difference, the record written in the trail file and the timestamp of that record in the data source. So for the pump, the actual lag is data written in the source trail file and target trail file. Okay, that is the actual lag for the pump. Okay, but it will show the sum of lag of the extract and pump when I will use the command of lag. So there are different ways to see the lag. So so there is one command lag. You can add the process name. It will show you the lag of the last transaction. You can do send process name get lag. Also this will show the last transaction lag. Info all, and the info all command, it will show lag of each process at as per the checkpoint file and time in seconds in the last checkpoint. So for us, if I want to see the lag of the database, how much lag is there in the committed, then I have to see the first column, that is lag at checkpoint. Okay, I'll let you know about time since checkpoint as well, but lag at checkpoint is the column we have to concentrate on for the lag. So now if somebody wants to monitor the lag on the error log files, then we have different commands we can add in the manager parameter, where we can get the what I say, the lag reports in the report files. So if the lag is increasing or lag is increasing for some time, then I can get these messages in a gg's error.log file as well, using the messages of lag report minutes, lag report hours. So lag report minutes, if I say lag report minutes 10, it will send the at 10 minutes it will send the lag messages, or the I will say the actual lag of each process into the gg's error.log file, so that if I'm monitoring the gg's error.log file, I can see the lag over there. Okay, so these critical minutes, critical hours and critical seconds will show me critical message in a critical format. Okay, you have seen in the ggserver.log there is a message with the critical info and warn. Okay, warn stands for warning. So if I say lag critical hours 1, that means is if the lag of any process increases by 1 hour, then it will send a critical message to the error log file. Similarly for critical minutes, if I specify 30, after 30 minutes it will show me the error messages. Okay, similarly for seconds as well. and then we're critical, then we can send info messages as well, and we can send the critical messages as well. So there's an example at the bottom where show lag report minutes 10, lag critical seconds 20. What it does mean is every 10 minutes it will send a message to the ggs error.log file if any process has a lag of more than 20 seconds. Okay, so in the time since checkpoint, time since checkpoint is the time in which how long it has taken to return to a checkpoint file. So this lag will increase some ways in some scenarios where there are long running transaction. With a long running transaction, it is reading the trail file. Extract is reading the extra trail log files and is not able to commit. Okay, not about the extract, but I would talk about, just assume for a pump is reading the trail file, so pump will keep on showing the this time since I keep on increasing because it's not able to commit. If not able to commit, uh, this message is not going to the checkpoint file as well. Okay, these would be rare scenarios, but this can occur. Don't need to worry, immediately take an action, but we can have to analyze in deep. Okay, what is happening internally, what it is reading. Similarly for the capture process, it is reading, but not able to write to the trail files. Similarly for the replicate, it can occur. Okay, so it's not able to write to the checkpoint file. Sometimes it might not write to the checkpoint file because checkpoint file itself is not there, corrupted or something. It can be occurred due to as well. So there is a position, there is, we need to analyze it as well. Okay, in detail what is happening actually. Okay, also lag at checkpoint would be the actual lag time, and time since checkpoint is the time it has not written. So time it has not written to the checkpoint file. And when does it write to the checkpoint file? It writes to the checkpoint file whenever there is a commit. Okay, so let's move to the next topic and we'll continue the performance tuning as well.